So here is my rational function. So firstly, I will factor the numerator and the denominator out to see if we have any terms in common that can be cancelled out. So here, as you can see, we have x plus 5 in common that can be cancelled out. So our wholes would be x equal minus 5, and to find y, we will plug in the negative 5 into the simplified equation, which gives us 0.7. So our whole would be at minus 5, 0.7. And then we find the vertical asymptote. To do that, we would set the denominator equal to 0, which gives us x equal 5. And to find the horizontal asymptote, we would divide all of the terms in our equation by the highest power of x, which is x squared in this case. And after simplifying and set x to infinity, we got our horizontal asymptote at 1. And then we'll have to find the x-intercept. To do that, we will set the equation equal to 0, and so for x, so our x could be 2. And then we'll find the y-intercept by substitute the 0 for x into the equation, and we have 0.4, so our y-intercept would be at 0.4. So here I create a horizontal table of values. So I would choose the values of x that are really close to the vertical asymptote, which is 5 in this case. So I would try to substitute the 4.999 and 5.001 into the function to get the corresponding values of y to see the behavior of this function. Then I would try one really small value of x and one really large one, so I chose minus 1000 and 1000. Also, to have a more accurate graph, I substitute another 4 values of x into the function, and I chose 1, 4, 6, and 7. Now we have all of the necessary information to graph this rational function. So we have the vertical asymptote x equal 5, a horizontal asymptote y equal 1, a whole at minus 5, 0.7, one x-intercept at 2, 0, 1 point at 1, 0.25, 1 point at 4, minus 2, 1 point at 6, 4, 1 point at 7, 2.5, and also we have one y-intercept at 0.4. And as you can see in the horizontal table of values, as we approach the vertical asymptote from the left, the function would go very negative. And as we approach the vertical asymptote from the right, the function would go very positive. So the end behavior of our function would be like this. Also, as the x gets smaller, the function would go closer to 1 but smaller than 1. And as the x gets larger, the function would also go closer to 1 but bigger than 1. So our end behaviors would be like this. So now from one behavior, we get to our whole and skip the whole through the other coordinates and connect to our other behavior. Same thing with the other side, we go through the coordinates, get closer and closer to the asymptote, and connect to the other behavior.